Hello everyone, let's talk about an easy problem on Leetcode today. Leetcode number 1 to sum. It is one of my favorite problems. So the problem states that given an integer array nums and an integer target, return the indices of two numbers such that they add up to the target. So that is why it is called to sum. So basically pick up two integers from the array such that the target so such that they are equal to the target, and they are saying that you can assume that the input array is given in such a way that there is only one solution, and the answer can be in any order. Now let's look at the example. So they gave first array as nums as 2, 7, 11, 15, and then the target is 9. So we add up 2 and 7 and we get that target. So that's why nums 0 and nums 1, that is indices 0 and 1, gives us this number. Similarly, in the example 2, they gave 3 to 4 as an input array, and then target is 6. So we can add 2 and 4. That's why indices are 1 and 2. And finally, they gave one more example with 3, 3, and the target is 6. So we add up to those two numbers, and actually the target is 6. So we get 0 and 1 as the answer. Now let's jump into how we can solve these problems. Now let's look at this array 5370142. In this, our target is 5, so we can achieve it in multiple ways: 5, 0, 3, 2, or 1, 4. I know in lead code problem they said that they guarantee that the array will have unique answer, and in this array that is not the case. But what I want to mainly cover is a concept here. So please ignore that point. And also I'll be focusing on the numbers rather than indices. Solving for indices will become easier once we understand the concept. So now let's look at the solutions possible for this one. The easiest answer for this is that we can go for a brute force, right? We can take this array and our target is 5, of course. So we can start looping from number 1 and number 2. So what we can do is, like, once we will start with I equal to 0, and then j will be I plus 1, because we will start looking at the next number and complete the loop like this. For example, if our target is 5, in this case, our first two numbers will be 5 plus 3. They will not be equal to target. So we will continue, increase the j. Now j will be, nums of j will be 7. So again, we add up those two numbers and our target is not matched. But eventually when we get 5 or 0, and then again the target this time matches, because 5 plus 0 is actually target. And this will be one scenario, one way to actually solve this problem. Now, if you notice, we were lucky that we just got this number when j was equal to 3. But actually this solution is not great. Why? Because we loop from first from I to j. So suppose our target was 7 instead of 5, so, or 8, for example, right? So in this case, what we will do is, like, eventually I will increase, because or actually we will find the answer in this case as well. But um, now let's think about some number which is like 11. Yeah, 11 is a good number to search. So in this case, what will happen is we will start looping to the array, like from the array. So once we are done to the end of it, like 5 plus 7 will give 12, or 5 plus 1 will give 6, 5 plus 4 will give 9, and then 5 plus 7, 5 plus 2 will again give 7. So we will not find the target, which was 11, right? So now we will do I plus plus, and that means I will be now equal to 3. Then again we will not find any solution. Then I will be equal to 7. And now once we start looping, when j is at 4, that is where we will find our answer. But the time complexity in this case is O of n square, right? And now the question is, can we do better? And answer is yes. That's why I think the solution, this problem is really good. We can see multiple solutions and the impact of it on the time complexity. Next solution is, how about we sort this number and then do some, will it help us in some way? And the answer is yes. So what we can do is, like, we can sort the numbers, and now our array is like that. So now we can use two approaches. Either we can do a binary search. So for example, our first number is 0. Then what we have to do is we have to just do the binary search on this array for 5. And we know the time complexity of binary search is O of log n. So our first sorting will take O of n log n. And once we start finding the elements after iterating, so it will be again n log n, because we will be iterating I from 0 to n minus 1, and rest of the elements we and target minus 5. So in this case, why we are searching for 5? Because our target is 5, because our first element was 0, and then 5 minus 0 is what we want, right? Target minus 0 is 5. So we will just search for that in the array, and if we find the answer, that is that is, I think, good enough. But we have to loop through all the elements and find the target minus that element throughout the array. Another approach can be that we start looping from left and right using two-pointer approach. Then we don't have to use binary search. Indirectly we are, but yeah, directly we don't have to. So what we will do is, like, our first element is 0, and the last element is 7, and that is more than 5. So we should reduce right, because on the right side the numbers are bigger, and on the left side the number are smaller. So in this case, we will do r minus minus, and our pointer now shifts to 5. And again, this time we will say, okay, is a of left plus a of right is equal to 5. That is our target, and actually that is the case. So we found the answer. But suppose we don't find the answer, then we can actually continue going toward moving the the right pointer towards the left. And similarly, if the numbers are like if the sum of these two elements, that is the left and right pointer elements, is less than target, then in this case we will move L to the right, because we are now searching for the bigger number. So think of this sorted array is like a mountain. So it depends, like if our solution is somewhere here, then either we come down or we come up, and that's what I think left and right pointer are doing. Now the time complexity in this case will also be O of log n log n, right? Because we have to sort the array, and then this using the two pointer approach, our time complexity will be O of n, but overall time complexity will still stay O of n log n. But now the question is, as a computer scientist, we always ask, can we do better? And the answer is yes. What we can do is, like, this is where I think what you say, a data structure called hash map can come into the picture. And this actually gives a very good illustration of what hash map can do, or how to use the hash map. What we can do is, like, we don't have to do any sorting or anything. We can start iterating onto the array from left to right or right to left. It's up to you. But let's say we start from left to right. We have the element 5, right? And we see target minus 5 is 0. And is 0 in the map? The answer is no. So what we will do is, like, we will just continue. Why we have to search for 0? Because that's what makes a target, and that will give us the answer, a quick one. And beauty of hash map is, like, it takes O of 1 time. So in binary search that we were doing earlier, it was taking O of log n time, but hash map is even more faster. And now once we but why then what is the problem with hash map? The problem with hash map that I can think of is, like, we are using extra space, while in case of binary search we don't have to, but we will come to it later. So now what we will do is, like, we will go to next element. We will increment the I, right? So we will see if nums of I minus 3 like exist sorry, target minus the nums of I exists in the hash map. Answer is no, right? Because 2 is not present in the map. So we will again add it to the map and increment the counter. Then we go, now we are at 7, right? And now we will again see t minus 7 exists in the map. Answer is again no, so we will continue like this. Now eventually we will get to 0, and this is where now the magic trick comes into picture. Is like we will see, okay, t minus 0 is 5. Is 5 already in the map? And the answer is yes, and that means we have found the indices. um, so I think comparing the time complexities, this will just take O of n time, whereas sorting will take O of n log n time, but it will not take any extra space. So sometimes programmers actually, or the interviewers actually say that your solution should not be taking extra space. Then I think that's the only, that's the best we can do. But if we are allowed to use extra space, in this case, we are using hash map, right? So for this, so in this case, I think we will be using extra space, but our time complexity will be O of n. So in computer science, everything is about trade-offs. Now let's jump into the code part. Now that we have understood the solution, I think coding it is not that hard. I will just go with the map solution because that's what I like the most, given the time complexity is just O of n. Um, so what we will do is just we will map to we need map to actually map the ith index number with the target minus nums I, right? That and just and we will just keep on checking till we find the solution. In case we don't find the solution, I think we can just return -1 for the index, right? So what we will do is like I less than nums or length plus. So we will say that if map, let's see what should it be the other number. So other number should be equal to target minus nums I. So we will first see if map dot contains key other number. That means we have found the solution, right? And our answer should be return new int, right? And that should be so one of them was the previous index. So what we will say, what we will be storing is the index as a value. So what we will get is like other number and index, and that will be coming from map.get other number, right? And that will be our answer. So other number comma current index, because that's what we want. Else what we will do is like we will just save this number into the map. So what we will do is like map dot put the current number nums I and its index. That's it. And one if we find something within the loop, all is good. Otherwise we will just return -1 -1 as the answer. So let's see if this code actually works. And the answer is no. I have to see why. Because what I am outputting is 2 and 1, but which is strange because the expected answer should be 0 and 1. So let me loop over the what do you say, the array that is given as an input. So when I see 2 and target is how much, 9, so we see 7 is in the map or not, uh, and the answer is no. So I will just put 2 into the map. Similarly, if I will then I will just increment the value of I. So in this case, again, the target number will be 9 minus 7, which is 2. And the answer is, that's why, because I am returning other number. I should be returning other number index, and that should fix the error. Yeah. Yes, this time it works. So let's again submit the solution. Yes, the answer works. I hope you enjoyed the solution. This solution has many variants like three sum, four sum, five sum, and or n sum, which becomes very interesting. And the idea is same or similar. And of course, we'll be seeing them in the coming days. I hope you enjoyed the solution. Thanks again. Have a nice day.